Okay, so let's try to construct a vector field whose curl is not zero. So let's say we have a vector field that depends on y, but it only has an x component. So we have y I hat. So let's map this vector field out. So let's say this is the x direction, and this is the y direction, and the z direction is out of the page. So let's say we're at y equals 1, right? When y equals 1, so we are, right, there's no x dependent. So as I move along the x direction, we always have the same value, which is 1. And so at every point here, I'll make a vector which is 1 in the x direction. So it's pointing to the right. So let's make a few arrows indicating the vector field A at different points. To the left here, we still have arrows pointing to the right. I made 4 here, so I'll make 4 over here. When we are below 0, so at y equals 0, we have 0. And at -1, we flip the direction of these vectors. So although we won't be drawing them at the same place, it's kind of nice to just, so right, we're drawing the vector field here, whereas here we do the vector field there. But we'll do something like that. So we'll draw 4 arrows indicating, so this is y equals -1 here, and this is y equals 1. And so we can see that at y, as y gets larger, the arrows have to become longer. So I'll make fewer arrows there. The direction is still the same for negative x values. Something like that. So the arrows all have the same magnitude here. They're greater. So, and down here, they just flip direction. So it's something like that. Same is true on this side. And so on. And so we can sort of see that this vector field has arrows above pointing to the right and arrows below pointing to the left. And so it kind of circles around this way, clockwise. So let's calculate the curl of this vector field. So what is the curl of A? We know what the expression is, and we also know that we only have one component, which is the x component. And so we see that the x component of A, ax, appears in 2 places. Derivative of the x component of A with respect to z, j hat, minus the derivative of the x component with respect to y, k hat. And so we see this doesn't depend on x, it depends on y. Take the derivative of y with respect to y, that's 1, so we get minus k hat. So we can see that this is a vector field where the curl of the vector field is not equal to 0. It's equal to a vector. Perhaps it's not surprising that the z direction emerges from this, indicating that there is rotation about that axis in one direction.